Hi students, coming to our next topic, that is query processing overview. So let us see what is the query processing. Actually, query processing is a procedure of transforming high level query. So that high level query you call it as SQL. So it is a procedure of transforming high level query SQL into low level language. So for that reason we are using the query processing. So this query processing is helpful to transforming high level query into low level language. So the basic steps of query processing is, first is the parsing and translation. Second, it is doing optimization, and next it is doing evaluation. So these are the basic steps in query processing. So first what it does, it parsing and translation. After that translation, it doing the optimization work. After the optimizing, then only it evaluate the query. Okay, so these are the steps in query processing overview. So let us see in this diagram. The first is the query, so which is in high level language. This is a high level query. So this high level query will be translated into low level language at last. So here you will get the low level language query. Okay, so here the high level query, first it converted into parser and translator. So what that parser and translator use the query? So first it takes the query from the user. Okay, so the parser and translator translates query into internal form. Okay, first it translates the query, whatever the query we are given, into internal form, and then translates into relational algebraic expression. Okay, so the translator first converts the query into internal form and it translates to that relational algebraic expression. Whereas parser is checks the syntax and verify the relation. So that is the work of the parser. So first we are taken the query from the user, and that query will be placed on the parser and translator. Here the translator will convert the query into internal form, whereas the parser is used to check the syntax and verify the relation. So after that the expression enter into relational algebraic expression. So that relational algebraic expression will be sent into optimizer. So here what this optimizer will do? So whatever the SQL query we are given, that now converted into relational algebra expression. Okay, after that that relational algebraic expression will be optimized. Optimization means it increases the performance of query by selecting the best query. Okay, relational algebra will give 2 or more queries. Okay, 1, 2 or 3 more queries with the same relation. Okay, so in that this optimizer will select the best query. Optimizer select the best query. Suppose A and B are 2 queries. Okay, these 2 queries, here the optimizer will select the best in A and B. So then you can say A is optimized than B. Means A is the best query when compared to B. Here we are just comparing only these 2. Okay, we are not comparing entire database, only the relation between the whatever the queries we are taken. Okay, so that is related to relational algebraic expression. So the relational algebraic expression can be expressed in different ways. Okay, in the different ways, different queries, this optimizer will select the best query. Okay, and that will be placed on the execution plan. Now the execution plan will execute the engine, takes the execution query execution evaluation plan and place it in on the evaluation engine. Okay, so here the statistics and about the data, this helps it consists of DBMS catalog. Okay, so what the statistics about data will do, it is a metadata, data about data. It is used for the best evaluation of query. Best evaluation of query. So it helps the optimizer for best evaluation of the query. So after evaluating the best query, that will be placed on the execution plan. Now that execution plan will send that plan in the form of in the form of a tree. Okay, so query tree. Execution plan, always the plan will be represented like it is in the form of trees, then only it will be understand. Okay, so that execution plan will send it in the form of query tree and place that best query tree in the evaluation engine. Now the evaluation engine takes the best plan and returns the answer to the query output. Now you will get the best answer. Okay, so this evaluation engine is having the buffers, like some data, extra data will be present. Okay, so it will stores in this data, and this evaluation engine takes the best one, and whatever the next data, that will be placed on the query output. So this is the query processing overview. First it takes the query. Okay, after that the parser and translator will convert the query into internal form, and it also checks the syntax and verify the relation, whatever the query that is, and it is converted into relational algebraic expression. So that expression can be different expressions. In that different expressions, the optimizer will select the best query with the help of the statistics about data, which you call it as a DBMS catalog. So with the help of this DBMS catalog, it selects the best query and placed on the execution plans. Okay, execution plan convert that into form of query tree, and it placed in the evaluation engine. Now the evaluation engine will send that selected query into the query output. So here you will get the answer, the exact query, whatever the database wants. Okay, so let us take one example. Okay, so suppose the query is like that. Means first we are taking the SQL query. It's a high level query. So first the query processor is a procedure of transforming. I already said it is a procedure of transforming SQL query to low level language query. Okay, so here first we have take SQL query, select book, title, price. Okay, select book, title, price from book, where the condition is price should be greater than 30. So this is the query. This query we have to select as a best query, means one best query we have to be select. Here given a book is a table name. So book is a table name. In the table we are having the fields like title, price, like author ID. So many fields are there. So in this table we are just selecting the book. Okay, so book is also another field. So in this title book, we are selecting the book, title, price, where the condition should be the price should be greater than 30. Okay, 10, 30, 40, 50, like that. Okay, so we have to select the price that should be greater than 30. So first what we have to do, whatever the SQL query, that will be converted into relational algebra. Okay, so we will write like sigma price greater than 30 pi of books, book comma, title comma, price from book. This is one relation. Okay, from this you can write like this in the relational algebra, or else you can write by book title price, where price is greater than 30 from the table book. So these two conditions, these two expressions are same. You'll get the same output. But in this two, we have this query optimizer will select the best query and place it in the evaluation engine. Okay. So this will be first what it does. So the query evaluation engine, the query optimizer will place the best query into the execution plan. So execution plan will convert that queries into query tree. Okay, what is query tree? Query tree is nothing but it is used to represent the relational algebra expressions. Okay, so the query tree represents into relational algebraic expression. Okay, so that expression should be in a tree data structure. Okay, and all the inputs relations are represented as leaf nodes. Okay, and all input represents relations are represented as leaf nodes, and the relational algebraic operators and the operators as internal nodes. Okay, so this will be the conditions. The query tree is used to represent the relational algebraic expression. So it is in the form of tree data structures. The input is as leaf nodes and the operators will be used as an internal nodes. Now let us see the query tree. So this expression will now convert into query tree. So first take the book. Okay, so after that you have to take this expression by book comma title comma price. Okay, after that the main expression by price greater than 30. So this is the one way of representing the expression, this expression in query tree. Now coming to this expression. So the first one is the book. Next it's calculating the price that should be greater than 30. Okay, next by book comma title comma price. Okay, so now the query optimizer will check these two relational algebraic expressions in the form of query tree and selects the best one. Okay, and place it in the query evaluation engine. Okay, so this will be placed, suppose this will be placed on the query evaluation engine based on the calculation of the cost, means how many cycles the CPU is taking to run this query, or how many disk access is required for evaluating the expression. So based considering all those points, okay, measuring cost of these queries, the query optimizer select the best query and placed in the evaluation engine. Okay, so the main important note here is different evaluation plans for a given query. So whatever the query is there, for a given query there should be different evaluation plans, can have different cost. So each evaluation plan is having separate cost. So it is the responsibility of whose responsibility? It is the responsibility of query optimizer. So query optimizer responsibility to select the best query to generate least costly plan. Okay, so from these two queries, the query optimizer will generate the least costly plan and place that in the query evaluation engine. Okay, so this is about the query optimizer. Thank you.